Hey guys, welcome to episode 7 of the series on circles. Alright, so in the past 6 episodes, we have discussed few example problems and all the concepts related to circles. From this episode, which is episode 7 of the series, we are going to focus only on problem solving. In this episode, I have handpicked and chosen few good questions from the question papers of various coaching institutes. The questions that we are going to solve are really good questions that gives you good exposure to all the concepts of circles. So we'll solve a couple of questions in this video. Let us go ahead. So let's have a look at the problem. The center of the circle C lies on the line, this line, and it cuts the circle orthogonally. Then circle C passes through two fixed points. Find those points. Alright. So this question is taken from the question papers of one of the famous coaching institute. So the center of the circle C lies on this particular line. Let us say center is h comma k. Now since the center lies on that line, we can write 2h minus 2k plus 9 is equals to 0. And it cuts the circle x square plus y square is equals to 4 orthogonally. Alright. Now let us assume the equation of the circle is x minus h whole square plus y minus k whole square is equals to r square. Now since this circle, so this is the circle that we have, this is circle C, and this is the circle given in the question, x square plus y square is equals to r square. Now if you remember, the condition for the orthogonality is r1 square plus r2 square is equal to d square, where r1 is the radius of first circle, r2 is the radius of second circle, and d is the distance between centers. So the radius of first circle, so this circle is 2 square is 4, and the radius of second circle is r square is equals to d square. D is the distance between centers. So the center of the circle is 0 comma 0, and the center of the circle is h comma k. So d square will be simply h square plus k square. Alright. Now let us go back to this equation. So this can be written as x square plus h square minus 2hx plus y square plus k square minus 2yk is equals to r square. R square is h square plus k square minus 4 from here. Alright. So this and this gets cancelled. This and this gets cancelled. So x square plus y square minus 2hx minus 2yk plus 4 is equals to 0. Alright. Now let us do one thing. So we have this condition in h and k, and we have this particular condition in h and k. So now let me rearrange this equation into this format. Minus 2xh minus 2yk plus x square plus y square plus 4 is equal to 0. Now we have this equation as well. 2h minus 2k plus 9 is equal to 0. 2h minus 2k plus 9 is equals to 0. Now we can compare these two equations, and we can compare the coefficients of h and k. Alright, h and k. So we can write minus 2x upon 2. So this upon this is equals to minus 2y upon minus 2. This upon this is equals to x square plus y square plus 4 upon 9. Alright. Now this is simply minus x is equals to y is equals to x square plus y square plus 4 upon 9. Now what can we do? So what we can do is, From this we have y is equals to minus x. Now let us take these two. Y is equals to x square plus y square plus 4 upon 9. Alright. So 9y is equals to x square plus y square plus 4. Since y is equal to minus x, let us substitute that. This is minus 9x is equal to x square plus y is equal to minus x. So y square is simply x square plus 4. So that will be 2x square plus 9x plus 4 is equals to 0. This can be written as 2x square plus 8x plus x plus 4 is equal to 0. So that is simply 2x into x plus 4 plus 1 into x plus 4 is equal to 0. X is equals to minus 4 and x is equals to minus half. So we got two values for x. So the values of y will be simply minus x. So the first point is minus 4 comma 4 and the second point is minus 1 by 2 comma 1 by 2. These are the 2 points, 2 fixed points from which the circle C always passes. So initially we have applied the condition of orthogonality and we got a we eventually reached at this particular condition in H and K. We have one more condition in H and K. So therefore we tried to match those equations by taking the ratios of the coefficients. So basically this equation and this equation has to be the same. So that those equations will be same only when the ratios of coefficients are equal. And by that logic we got the two fixed points which are minus 4 comma 4 and minus 1 by 2 comma 1 upon 2. Alright. So these are the 2 points. So whenever you encounter such questions, so this idea should click to you. So this is the important idea, taking the ratios of coefficients that we have used here. Alright. Let us proceed to the next question. Okay, again this is a classic problem. So 3 circles centered at points ABC and of radii 5, 5 and 8 units touch each other externally. So there are 3 circles. So the first circle has the radius 8 and the second circle has the radius 5 and the third circle also has the radius 5. All these 3 circles touch each other externally, something like this. Or let's something like this. So these are the points of intersections. I mean the points of tangencies. Alright. So the radius of this circle is 8 and these two circles are 5 and 5. Alright. Now what we are asked to find out is two circles C1 and C2. One smaller, so C1 is the smaller circle, other bigger, C2 is the bigger circle that touch all these 3 circles. Okay. So we should draw a circle that touches all these 3 circles. So one way to do that is to draw a circle here. So this is the smaller circle C1 that touches all the 3 circles. Alright, this is the circle. And we have to draw a bigger circle as well. So that can be drawn like this. If it touches all these 3 circles externally, so this circle will be the circle that is touching externally. So the red circle is C2 and the green circle is C1. Now we have to find out the radii of these 2 circles. So let us find out the radius of green circle first. So let us say this is the center of this circle, centers. So these are the centers, let us say. So now what can we do? So let's do this. So this is 5. All right. And if you join this is 8. All right. And similarly, this is 8 and this is 5. By the same logic, this is 5 and this is 5. All right. Now let's say the center of the circle lies somewhere here. Now let us try to join these things. Alright, so let us say the radius of inner circle is r, the radius of green circle is r. So then this length, this green length is simply r plus 8. This is r plus 8. This is r plus 5. And this is also r plus 5. Alright, so now we have to find out the value of r. So now what we can do is, let us mark these points. This is A, this is B, this is C, and now let us extend this particular line till here, and let us say this point is D. Now triangle A D B is right angle triangle since angle D is 90 degrees. Therefore AD square plus BD square is equal to AB square. So your AD square is not known. AD square plus BD square is simply 25 is equal to AB square is simply 169. So therefore AD will be 12. If you solve it, you will get AD is equal to 12. Alright. Now AD is equal to 12. Again, AD is equal to 12. Now what we will do is, we will consider, let us say this center, the center of this circle is O. Alright. Now consider triangle ODB. So that is also a right angle triangle. Therefore OD square plus BD square is equal to OB square. Alright. OD square is not known plus BD square is 25 is equal to OB square. OB square is r plus 5 whole square. Alright. Now from this we can calculate OD square plus 25 is equal to r square plus 25 plus 10r. So this and this gets cancelled. So OD square is equals to r square plus 10r. So we got OD square is equal to r square plus 10r. So OD square is equal to r square plus 10r. So let us erase the other stuff, unwanted stuff here. So we have calculated AD and OD. Alright. Now we know that AD is equal to AO plus OD. We know that AD is 12. We have calculated here is equal to AO is r plus 8. Alright. Plus OD is square root of r square plus 10r. We have calculated here. So this is square root of r square plus 10r. Alright. Now let us try to solve this particular equation. So this is simply, if you send 8, this 8 to the other side, you will get 4 minus r is equal to square root of r square plus 10r. Squaring on both sides, we will get 16 plus r square minus 8r is equal to r square plus 10r. R square will get cancelled. 16 is equal to 18r. R is equals to 16 upon 18, which is same as 8 by 9. So the radius of inner green circle is simply 8 divided by 9. I hope this is clear. Alright. Now let us proceed to the next part of the problem. It touches this circle at this particular point, and this circle at this point, and this circle at this point. Now since, okay, let's say this is the center of the circle, and this is the center of the circle, and this is the center of the other circle. Now if you join these centers, your center of this red circle, your center of the green circle, I mean the smaller circle lied here. Your center of the red circle will lie somewhere here on this particular line. All right. So this is the line of symmetry. This green line is the line of symmetry. So the center of red circle will lie somewhere here. All right. Because this is a circle of bigger radius and these two are circles of smaller radius. So it will lie somewhere here. Now, so it lies somewhere here. So now this length is 8. Let us say this total length is the radius of the bigger circle. Let us say that is R. Then let us say this is A, this is B, and this is C. The center is O. Alright. Now your AO is simply R minus 8. And your BO, so this particular length is simply R minus 5. So this total is R and you are subtracting the radius of this circle from it. So that will be simply R minus 5. Similarly, your OC, CO is also R minus 5. Consider this particular triangle. Alright. So let us say this point is P. Now BP square plus OP square is equal to OB square. Alright. BP square is simply 5 square plus OP square. OP square is, what is OP square? So this length is R minus 8. Alright. So we have already calculated that AP is 12 while doing the previous question. Alright. AP is 12. So OP is simply AP minus AO. So your AP is 12 minus AO is R minus 8. So minus R plus 8. So this is simply 20 minus R. So OP square is 20 minus R whole square is equal to OB square. OB is R minus 5. R minus 5 whole square. Now you just have to solve this particular equation. So the reason why I have picked this question is I want you guys to understand how to solve these questions. You have to get all these ideas by yourself. Which triangle to consider, where will the center of the big circle lie, all these ideas. If you're not getting these ideas when you look at the problem, try to watch the solutions of some problems like these which I'm presenting and then give similar questions a try from some other test series or some other book. Alright, so this will be 25 plus 20 square is 400 plus R square minus 40R is equals to R square plus 25 minus 10R. R square 25. These things will get cancelled. Now 400 is equals to 30R. So R is equals to 40 by 3. So the radius of your smaller circle C1 is 8 upon 9 and the radius of your bigger circle C2 is 40 by 3. Now you know how to solve these kind of questions. Alright. Okay, let us proceed to the next problem. So this is our next problem. 6 distinct points xi, yi for I is equal to 1 to 6. So we have 6 distinct points x1, y1, x2, y2, x3, y3, x4, y4, x5, y5, x6, y6. So we have these 6 distinct points are taken on the circle x square plus y square is equal to 4. So the circle equation is given. So the center of the circle is 0, 0 and the radius is 2, r is equal to 2, and the equation of the circle is x square plus y square is equal to 4. Very generic circle, such that sigma xi is equal to 8. So x1 plus x2 plus x3 plus x4 plus x5 plus x6 is equal to 8. So this is given, and sigma yi is 4. So y1 plus y2 plus y3 plus y4 plus y5 plus y6 is equal to 4. This is also given. So let us say these 6 points are somewhere like this, very random points, alright, somewhere like this. And now what are they saying? The line joining the orthocenter of the triangle found by any 3 points. So we have to take any 3 points and we have to get the orthocenter. So let us say this is x1 y1, x2 y2, x3 y3. Let us say, since they are saying we can take any 3 points, so we will take these 3 points. Okay, x1 y1, x2 y2 and x3 y3. We have to find out the orthocenter. Okay, so there is a point O which is the orthocenter formed by these 3 points. Alright, x1 x2 x3, x1 y1 x2 y2 x3 y3, and the centroid of the triangle having the vertices at rest of the 3 points. So these 3 points we have to take the centroid, so G. So the line joining these 2 points passes through a fixed point h comma k. So now they are saying this line passes through a fixed point h comma k and we have to find out h plus k. So let us try to find the equation of this line. Okay, now if you consider these 3 points, alright, so they form a triangle, correct? They form a triangle. Now what is the circumcenter of this triangle? So now we are talking about the 3 points x1 y1, x2 y2, x3 y3. What is the circumcenter of these 3 points? Circumcenter of these 3 points is origin, alright, because these 3 points are at equal distances from origin. So the point which is equidistant from all 3 vertices of the triangle is circumcenter. So the circumcenter is origin. Now what is the centroid of these 3 points? Centroid is x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3. Then what is orthocenter? So you must remember, you must recall a fact here. So there is something called as Euler line. Euler line. So O is your orthocenter, G is your centroid, and S is your circumcenter. Then OG is to GS. OG is to GS is 2:1. Now this is known to us and this is also known to us. Alright, x1 plus whatever. So G is also known to us. Let us say the coordinates of orthocenter are A comma B. Now let us apply section formula. M x2 is 0 plus n x1 is A by m plus n, m y2 plus n y1 by 3 is equal to the centroid. Alright, equating the x coordinates will get A by 3 is equal to x1 plus x2 plus x3 by 3. Since in the centroid x coordinate is x1 plus x2 plus x3 by 3, here the x coordinate is A by 3. So we get A is equal to x1 plus x2 plus x3, and similarly we will get B is equal to y1 plus y2 plus y3. So therefore orthocenter of this triangle is x1 plus x2 plus x3 comma y1 plus y2 plus y3. Now for this triangle, for these 3 points x4, x5, x6, we have to find the centroid. So what is centroid? That is very simple. So orthocentre, this O comes here, and G is centroid formed by other 3 points. So that is simply x6 by 3, y4 plus y5 plus y6 by 3. Now we have to find the equation of this particular line. Alright, orthocentre is x1 plus x2 plus x3. This is y1 plus y2 plus y3. Alright, now x4 plus x5 plus x6 is simply 8 minus x1 plus x2 plus x3. So this is simply 8 minus x1 plus x2 plus x3 by 3. Similarly, y4 plus y5 plus y6 is simply 4 minus y1 plus y2 plus y3. 4 minus y1 plus y2 plus y3 by 3. Alright. Now let us denote x1 plus x2 plus x3 as alpha and y1 plus y2 plus y3 as beta. So this point is alpha comma beta, and this point is 8 minus alpha by 3, 8 minus beta by 3. Now let us we need the equation of this particular line. So let us use the 2-point form and find out the equation. So y minus y1 is equal to m. M is beta minus 8 minus beta by 3 by alpha minus 8 minus alpha by 3 into x minus x1. Alright. So when you solve this, you get y minus beta is equals to 3 beta minus 8 plus beta by 3 alpha minus 8 plus alpha x minus alpha. Further simplify it, you will get y minus beta is equals to 4 beta minus 8 upon 4 alpha minus 8 into x minus alpha. So y minus beta is equals to beta minus 2 by alpha minus 2 into x minus alpha. Alright. Now this is the equation of the line we got. Now let us rearrange it a bit. You can write it as y minus beta by x minus alpha is equal to beta minus 2 by alpha minus 2. Alright. Also, now let us simplify it further. Let us rearrange it a bit further. So this can be written as beta minus y by alpha minus x is equals to beta minus 2 by alpha minus 2. So now compare the left hand side and right hand side. So this line always passes through the point 2 comma 2. If you put y is equal to 2 here, irrespective of what alpha and beta are, so alpha and beta are your x1, x2 and x3, these points, correct? So irrespective of alpha and beta, when you put y is equal to 2 and x is equal to 2, LHS will be is equal to RHS. Therefore, this particular line always passes through the point 2 comma 2. Therefore, H plus K is 4. Alright. So these are the kind of problems that you should solve. I hope you got to learn so many things from this question. Alright. So you got to learn the Euler's, you got to recollect the Euler's principle, and then how to find the coordinates of centroid, orthocentre, realizing that the center of the circle is the circumcenter of the triangles formed, all of these stuff. This is a beautiful question that appeared in the test series paper of one of the famous coaching institutes. Again, here you got to learn how to find the radius of the smaller circle when it is touching all the three other circles, and also the radius of the bigger circle when it is touching all the three circles externally. Alright, again, this is also a very wonderful question. Every student who prepares for Olympiad and JEE should know these concepts and these methods to solve the questions on circles. Again, this is also one good question that we have solved. So that is all for this video. We'll meet in the next episode. So if you like the content that I'm making, make sure you subscribe the channel, share it with your friends, and do not forget to like the videos. If you have any queries in whatever I have explained in this particular episode, reach out to me in the comment section. Even if you have any generic queries, comment section is the way to go. Do check out the other videos on the channel, and I have a complete playlist for circles where I have started from the very basic concepts and went on up to advanced concepts. So make sure you check the playlist, and also after this episode I'll bring few more episodes where I'll be solving wonderful questions on circles just like today. Alright, so thank you for watching. We'll meet you in the next video.